Live and record. Math in the PM. Similar triangles, 7.4. This lesson, you'll be studying similar triangles by building on your knowledge of polygons. And the properties of similar triangles are useful for solving real-world problems. And actually, this is one of the units that actually really builds and is continued on in whichever type of math you take in grade 10, 11, and 12. Because it leads to something, you know those sine, cos, and tan buttons on your calculator? You don't, but other people do. If you have a calculator with sine, cos, tan buttons, that's what this leads into in the next couple of years. Because that's all about similar triangles. So, let's take a look here. Identify and name the three congruent triangles in this diagram. Now, the first one that's obvious, I hope you think it is this one that I'm outlining. PQR, correct? So let's list it down. That's my discipline. Triangle PQR. Congruent. So, okay. Actually, I won't use this green. I'm going to go with PQR in green. Now I'm going to use a different color for the next one. What's another triangle? It's smaller. I'm going to go PNS though, just because, and here's why. I went P down to the right angle, QR. So I'm going to go with P down to the right angle, then S. But yes, you're 100% correct. So I'm going to use blue for that one. PNS. Funny name, man. Anyway, glad you're amused. What's the third one? Same angles. STR. Thank you. Okay. I think we can all see this, right? And I'm using a wavy line over top of the equal sign to be congruent. And it's not equal. The angles are equal, but the sides are proportional. That's what that means. That's why this is the unit or the section called similar triangles. What are the corresponding angles in the two largest? Explain. Okay. Corresponding angles. I'm going to just get the two largest. Well, see, here's my rough diagrams. I'm going to just put it over top. So, P, Q, R, and then the S, T, R. I'm going to just put that inside here. Just so that I have it to reference. Now, when I do it like this, it's pretty easy to see which is corresponding. Explain. So that'll be our explanation here. I'm going to say that angle P corresponds and angle S on this angle sign and then S. Okay, you guys, you know what? I don't think you should be sitting here anymore. 3 days in a row. Okay. I've got that down. I had stopped recording for just a second. Got that down? Good. Good. How can you use what you know about similar polygons to tell if the two triangles are similar? Because we were doing it didn't matter how many sides in the last section, probably many sides. So what do we need to have? We have to have exactly equal what? All angles are the same. One. What about the sides? They aren't the same. They are, what's the word we could use mathematically? Okay. Proportional is the word I use. But they all use the same multiplier to get to each other. All sides are proportional. That just means if I take one from the big triangle, divide by the little triangle, they'll come out to the same decimal number, no matter which of the three sides you compare. Okay? I'll let you drop that. Now, here's the thing though. With a triangle, you actually, if you know that the three sides, and this only works with triangles, not with four sides, five sides, etc. You have all three sides equal, or all three angles equal, it is guaranteed. You only need one of those things to be true. Okay? They're the same proportions, okay? So, I'm going to put starting. Either one of these. Now, I'm going to maybe pause this because I'm going to get up this investigation, but I think I might. So we're going to work through this. I'm just starting the recording again now. And the angles are measured. We've measured the actual sides. Now, to construct an enlargement, label its vertices, explain how you drew the enlargement. Well, first of all, we have to decide as a group, how large are we going to make this? Let's go 1 point what? 1.2 or 7? 1.7? Okay. Okay, it doesn't matter. We're just saying this. So, enlarge. So this is our explain how we drew the enlargement. So that's our scale factor. That means everything's multiplied by 1.7. So, over here on the right-hand side, I'm going to do some arithmetic. AB. Is going to be turning into 3.3. Oh, what did I write? 3.3 times 1.7. That's our multiplier, right? So let's call this DE. What is 3.3 times 1.7? 5.6? Okay. Let's go with 5.6, just because our rulers aren't that accurate. Then, from our BC measurement, so I'm going to take my BC measurement of 4, 1.7. So we're going to call that EF. That's going to be equal to 4 times 1.7. Use a calculator, please. I'll give you two things. Here we are. Okay. And we've got 20 centimeters. 6 fifths. And then the last thing, CA. So that's going to be 3.6 times 1.7. So FD is going to be equal to, and then we'll actually do the dots is. I can't do this in my head. You guys got the power to love it. So we'll go 6.1. Those are the lengths of the new size. And I'm going to make it a green triangle. It will be proportional to the original. So I suggest we start with the side that's similar to AB, and that's DE. Okay? So DE, green mark, I'm going to draw 5.6 centimeters. We calculated this, right? You guys are to draw the flat horizontal line. That one went over just a touch, so I'm going to my ruler matched up there. Okay, there's my 5.6, and I'm going to call that DE. Are you guys good? Yeah. Now, I can do something that you can't, but whatever. I'll show you what it is. You guys are going to have to use your protractor and do a 70-degree. I'm thinking of doing AC next. So 70 degrees, that means I put my corner on here, right? And I look, and I count 0, 10, 20, 30, 40, 50, 60, 70. And I'm going to make a mark at 70. There. I make my mark at 70. I made mine larger just so you can see it. Then I remove my protractor because I know that the corner at D to that mark that I made is going to be 70 degrees. This is D and S distance, right? 6.1. I'm going to use my ruler. Oops, oh, I got it. Mine is going to go past the letters. I think yours will too, won't it? It depends if you started a little higher. Good. Good for you. Now I'm going to draw that length of 6.1 because that's the FD distance. Larger. Oh, I'm going to erase light because that's on crooked. Try it again. I'm going to try that again because that was terrible. Why isn't, oh, the other times it catches on to the but anyway. None of it. Oh, the devil of a time. You guys draw your straight. 6.1. My ruler doesn't work as well as yours. No? Okay, that's just because of a little bit. That's what I was just going to say. We're going to just connect the other two ends. Yes? This one? Out. And make sure that this is 70 degrees. So here I measured with the protractor, 70 degrees. I made a dot, which I've erased since. And I make sure the line that I draw falls through that dot and it's 6.1 away. And it's because we have a bit of rounding piano when we were doing that too. And our degrees aren't always perfect, so they are out a little bit. Then the last one, as Kiana mentioned, hers isn't perfect. I'm going to just twist mine. Mine actually is 6.8. Yours is. But mine actually turns out, but that's just a little variance. Okay, my ruler doesn't work as well as yours to make straight lines. There it is. You really only have to measure one of the angles. Then the other two just have to be when you connect the dots or connect the ends. So if you measure them, they should be the 50 and the 60. Right? So I'm going to label this F. Okay. I'm going to put in the measurements. Okay. 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 Now a reduction. Choose a multiplier that's quite tiny. So I would go with decimal 4. Why don't we all do decimal 4? You can use decimal 5. What do you guys want? Do you want to be different, decimal 4 or 5? Elijah said 5. What are you guys going with? 5? Okay, decimal 5. Everyone decimal 5. Okay? I'll help you out. I'll just pause the video. So construct your next triangle with the decimal 5 so you worked out the calculations. And draw it in the open space up above. Okay? I'll just add into the video that we chose as a class, decimal 5 as a reduction multiplier. Or scale. Decimal 5. Draw it up above, it'll have the exact same angle, 70, 60, 50. Make sure on your tiny one that you got the 2 and the 1.8 and the 1.7. Redraw. Move my ruler out of the way. Okay, and if you need a hand, you just talk. Okay, be sure to label your sides and your measurements on the reduction. Okay. Then, on the next page, now I made it easier for me and you because you'll have the same measurements. The next page has this chart, right? So what you're going to do is you're going to take that chart and fill in this information from the original, ABC, then the DEF, and then the GHI. Okay? Fill in those charts, blanks, or the chart. Okay, it works. CA and AC is. Okay. So you're filling it in. AB is 32 millimeters. I'll use the same. AC is 40. 36. Okay, and then fill it in for that one, and then fill it in for the blue one. Okay. You guys go ahead and do this. You're going to, but you're not done. Okay. So, I can stop the recording, but you guys got something to do for the next 5 minutes. Fill in this chart.